Welcome to Unit 5. Today, we're going to talk about our counting principle. We're going to start with how many letter combinations can we make from the letters in dog. Remember, letters can't repeat. So pause for a second and give you about 30 seconds to write down as many combinations as you can using the letters without repeating. So the combinations you should have come up with are as follows: DOG, GOD, ODG, and so forth. So you have 6 combinations. So we're going to talk about a little bit later how to find that mathematically. In terms of, if I have 3 pants and 3 shirts, I want to know how many outfits can I make. So again, pause the video for a second and try to write down all the combinations to determine how many you can come up with. So the combinations that you came up with should have been as follows. So you end up with 9 different combinations. So again, we're going to get into a little bit of the math of how you came up with the 9 combinations and the 6 for the first one respectively right about now. So the computation of theoretical probabilities is based upon the multiplication counting principle. Okay? So, for example, if I have 3 sweatshirts and 2 different pairs of jeans, then I should be able to make 6 outfits. That's 3 times 2, giving me 6 outfits. So if we look back at what we just did involving our pants and shirts here, 3 times 3 is going to give us our 9 outfits. And we wrote out combinations as follows. So hopefully that makes a little bit more sense. So we'll look at the second example. We have internet domain names that must have more than 1 character. In general, companies like to shorten the domain names since they're easier and faster to type and to remember. How many 2-letter domain names are there? So if there are 26 letters in the alphabet, for the first letter, we have 26 choices. For the second letter, we also will have 26 choices. So if we multiply that together, we can have 676 2-letter domain names. Okay? So now, if we are to include numbers, and there are 10 digits that we have to choose from 0 to 9. So now, for our first character, we now have 36 choices. So that includes letters and numbers. And for our second choice, we'll have 36 choices. So now we have 1,296 two-character domain names. Example 4, the ice cream shop. We have 28 flavors of ice cream, 11 different toppings, and 3 sizes. So how many ways can we order the sundae with 1 scoop of ice cream and 1 topping? So if we have 28 flavors, 11 different types of ice cream, or different toppings rather, and 3 different sizes, if we multiply that together, we have 924 ways we can order the sundae. How many different gender arrangements are there if a couple has 6 children? So for the first child, we have 2 choices. For the second child, we have 2 choices. Third child, we have 2 choices. And hopefully you see where we're going with this. The fourth one, we have 2. The fifth one, we have 2. So if we raise 2 to the 6th power, we should have 64 arrangements for our gender. Okay? Alright, now, let's keep going. Suppose Whitney Gilbert wants to put photos of her 5 favorite students on the wall. How many ways can she do this? So she has 5 students to choose from for the first spot, 4 for the next, 3, 2, then 1. So she has 120 different ways. So expressions like 5 times 4 times 3 times 2 times 1, we write as 5 factorial. Hopefully you remember this from Algebra 2. So if you look in your calculators, if you press math and then slide over to probability, option 4 is your factorial. We're also going to be using options 2 and 3 for combination and permutations. But option 4 is your factorial. So again, math, slide over to probability, and choose option 4. So if it's 0 factorial, then that is understood to be just 1. Okay? Alright. So if there are 25 students in the probability and statistics class, there are 25 seats in the classroom. How many different seating arrangements are possible? So that's just going to be 25 factorial. So if you put that in your calculator, let's go 25, math, I know the probability, choosing option 4, enter. We can write that as 1.55, rounding correctly, times 10 to the 25th. Alright, so now pause for a moment and everyone find out, what if there were 30 seats in the classroom? How many seating arrangements could we come up with? So if there were 30 students, then we got 30 factorial, which would be 2.65 times 10 to the 32nd. Okay? So let's look at some special cases where we have 4 letters in the word math. You want to know how many ways we can pick those 4 letters? Well, that is just 4 factorial, which is going to be 24 ways. There are 4 letters. None of them repeat. However, in the word England, there are 7 letters. And we have the N here and the N here that repeat. And we have to account for them. So if there are letters that repeat, your numerator is however many letters there are, in this case being 7, so 7 factorial, with the repeat letters being 2, which gives us 7 factorial over 2 factorial. So in the word Jefferson, we have 9 letters, so that's going to be 9 factorial, divided by, we have 2 E's, so we're going to do 2 factorial, and we have 2 F's, So that's going to give us another 2 factorial. So that ends up being 90,720 different ways we can pick a non-letter word from the letters in Jefferson. So if we have the phrase, Cowboys Forever, there are 14 letters, so our numerator is going to be 14 factorial. Divided by, we have 3 O's, so we'll divide by 3 factorial. We have 2 E's, so we'll divide by another 2 factorial. And we have 2 R's, so we'll divide by another 2 factorial, which will give us a very big number, 3, 6, 3, 2, 4, 2, 8, 8, 0, 0. Okay, so that's the number of ways we can pick a 14-letter word from the letters in Cowboy. So remember, the numerator is however many letters you have, divided by, if there are letters that repeat, that count factorial. Now let's look at permutations. And the biggest thing to remember about permutations is that is where the order does matter. So if the order does not matter, it's a combination. Permutations, the order matters, such as with your phone number. We call this, like fill in the blanks, permutation. So you don't have to worry about the formula per se because the calculator is going to do it for us. Remember, if you go to math, side order probability is option 2. Math option 2. Math PRB option number 2. That's what we're going to be doing. Okay? So N. The larger number N will always go first. Okay? Remember that. Larger number N will always go first. So when you're doing this in your calculator, larger number N will always go first. R will be the number that we're choosing from that N. Okay? So if we want to know how many ways we can pick 3 different officers, president, vice president, secretary, so their rank matters. That makes it a permutation from 20 members. So that's going to be 20. And from those 20, we want 3 officers. So we do 20, 3. And now calculator. So 20, math, side order probability, option 2, 3, 6,840. So if you have one of the newer 84s, then if you go to math, PRB option 2, it literally comes up for you. You don't necessarily have to type the number first. So if I want to type a 6, how many ways can I pick a 6-letter word from the letters in Lakers? Well, there are 6 letters, so that's 6, P6, which anytime N and R are the same, it is the same as the factorial. So it's the same as 6 factorial, which is 720. So again, N and R are the same. You can just do the factorial. Probability